Hello students, this is Dr. D. I hope you're having a good day off. What I'm going to show you today is something called a match pairs T procedure. And if you've heard the term match pairs before, you're probably thinking back to our unit on experiment design. And the key premise in a match pairs design experiment is that we compare subjects to themselves. So typically we would give them a pre-test and a post-test of some kind. So let's take a minute to read through this problem. Police trainees were seated in a dark room facing a projector screen. 10 different license plates were projected onto the screen one at a time for 5 seconds each, separated by 15-second intervals. After the last 15-second interval, the lights were turned on and the police trainees were asked to write down as many of the 10 license plates as possible in any order at all. A random sample of 15 trainees who took the test were then given a week-long memory training course and they were retested. The results are shown in the following table. So it's sort of interesting to look at these subjects. Let's take a look at one of the subjects here. Let's look at the first subject. What you'll notice is this subject in the first column is how many plates they correctly identified after training, and in the second column was how many plates they correctly identified before training. And in essence, what we're really interested in a problem like this is the difference. Did this person improve because they went for training? And so in the way this table was set up, you'll notice the people after training are in the first column and before training are in the second column. That was probably done because you would expect most people to be maybe like the second subject. You look at the second subject, they remembered 8 plates after taking the training of some kind, while prior to taking the training they could only remember 5 plates for a difference of 3. So this person actually put a little star next to them. They actually improved, where the first person, they stayed the same. The training, you could say, was not effective. But if you look down this last column here, you'll notice you see quite a few numbers that are positive. Here's a 2, a 2, a 3, a 5. Here's 2 people with no improvement. There's sort of an interesting person coming up right here. Think about what that would tell you. So if you're thinking that person did worse after training, that's correct. This person remembered 3 fewer license plates after during training than they did before training over here. So sometimes, I guess a training program might not be effective or make things worse. All right, so what are we really interested in here? If you think about it, what we really care about is was the training program effective for the people who participated in the study? And so what we're going to do is we're going to make a variable. We're going to say let mu and be a minus b, where a is the number of plates correctly identified after training, and b is the number of plates correctly identified before training. And if our goal is to show this program is effective, then we want to compare 2 hypotheses. One hypothesis, the null hypothesis HO, would be that the mean difference between these 2 groups is 0. That in fact there is no improvement by going for this training. And take a second, think about what HA should be. Okay, so did you figure out that you really want this difference to be greater than 0? After all, if the difference is greater than 0, that would mean that this number here, A, was a bigger number than B was. And that would mean you had a positive difference. If we had a positive difference, that means the trainees are remembering more license plates after participating in this program. And that's a good thing because that was the goal of the program. Okay, so now what we're going to do is we're going to perform a t-test on this last column, the difference column. Right here, I'm circling it again, A minus B. So in order to do that, we're going to take these numbers, 0, 3, 2, 2, 3, 5, and so forth, this whole column, put them into our calculator because we're going to get ready to check our assumptions. So let's do that. Assumption number 1, as always, SRS. We're going to have to assume that. Number 2, the population of all police officers will be greater than 10 times our sample size, which is 15 in this case. That's going to be 150. Now what that tells us is that usually we can use the standard deviation of X bar formula. There's only one problem. While we have n is 15, so we can plug that in, we do not have S of X, but we can get it. We're going to go back to this table. We're going to take a minute and put all those numbers in the difference column into our calculator and find the mean and standard deviation of that list. So I'll give you a minute to do that. Okay, so hopefully you paused the screen and took a minute to do that. I ended up with a standard deviation of about 2.199. Let's just call it about 2.2 divided by the square root of 15. We should type that into a calculator and estimate that. Let's see what we get here. 2.2 divided by the square root of 15. We get about 0.57. Okay. While we're at it, we should also take a moment to make a note of x bar. We're going to need it later on. So I got an x bar of 1.533. So think about that in the context of the problem. That means that these trainees, on average, were remembering 1.53 license plates more after participating in the training. Okay, and then finally, the last thing we want to check in our assumptions is normality. But to do that, you would need a box plot. So if you took the time to set up a box plot, what you're going to notice about this box plot is it's not as symmetric as some of the ones we've been doing in class. It's got a longer tail on the left for sure. Looks something like this maybe. But we're going to say that this is close enough and that it's safe to use the T procedures. Over time, you'll get a better sense of what's okay, what's not. But this is only considered moderate skewness. And that's okay. We don't have any outliers either. So that also makes it safe. All right, so we're just about ready now. We can go draw a picture. Step 4, as always, draw a picture. Oh, that is, sorry, we're on step 3. Draw a picture. So here we go. Looks like a normal distribution, but we know it's a T distribution, specifically with degrees of freedom equal to 14. We're going to put HO in the middle, which was that mu was equal to 0, indicating that these people did not improve at all. And keep in mind, HA is that mu is greater than 0, so we're expecting that to happen. We mark off our 1.5. Now remember, x bar is 1.533, but we had an s of x bar, sorry, equal to 0.57. So actually this 1.53 is pretty far away. It's out here somewhere. And if we shade in the direction of HA, we get the area of the tail that we want. So if our goal is to find the area in that tail, we usually compute a t-score, which would be our x bar minus our mu over our standard deviation. Now when I divide that on my calculator, I get something around, say, 2.7. So that's a pretty big t-score. It's pretty far away. And if you take the time to look up in a chart or use TCF in your calculator, which I assume you'll do, then you would get a p-value equal to 0.0086. Whatever it is, some of you might be rounding differently, getting slightly different answers, but that's okay. Whatever it is, that is definitely less than alpha equals 0.05. 0.0086 is less than alpha equals 0.05, or even less than alpha equals 0.01, which is sometimes another alpha value that statisticians like to use. So what does that tell us? It tells us that we can reject HO in favor of HA. And that means in this case, what we've done is that we found there's a statistically significant difference between their post-training score and their pre-training score, that these subjects, these police officers, were indeed able to remember more license plates because they went through the training. And so that's an example of a match pairs t-test. What you'll notice is it's everything we do with the t-test, but we're looking specifically at the differences between a subject's pre-test and post-test scores, and we're testing to find out, is there a significant improvement? Did they do better on the post-test scores after the training than they did on the pre-test scores? Okay, so check Canvas for an assignment, and thanks for watching, and I'll see you tomorrow. Bye-bye.